Hello everyone, welcome to another video at INDICE Tech. In this video, I will build this complex 3D assembly from the scratch. This video is part of my journey to educate myself. At the same time, I am sharing my experience with you guys so that together we can learn. Also feel free to provide your feedback. Now, the first part of the video I will discuss about sketch, tips and tricks. Now let's get started. Right, now this assembly has 24 sketches in total. Now let's open the first one, the very first one. So this is a sketch, put the visibility on. So here you can see the first thing important for the sketch is that your sketch does not look green color. It needs to be dark. Dark means it is fully constrained. For sketching, modularity is important. To make your sketch modular, all the lines need to be constrained correctly. Then apply the dimension. So remember, constraint first, then the dimension. Then reuse those dimensions. As you can see, I have reused. So this dimension fx means it has already been reused. So fx r250, fx r250. So if I click on this, this is my dimension 1. As you can see, this is the dimension d1. Then this is the length of the component, and if I go to the width of the component, that's also I have used the formula. So this is basically d2. D2 is d1 divided by 25. Basically, I have reused the dimension value of the length to the dimension value to the width. Similarly, I have used other dimensions as well. Now I will share this 3D file with you guys so that you can open the whole assembly and see it all in your own time. At the manufacturing industries, many companies do not allow the designing team to use projected geometry, which I have used significantly in this tutorial. Now to avoid projected geometry, you have to use parametric designing. So make it a habit to use projected geometry only when you need it. Use symmetry and mirror features whenever possible to reduce repetition and improve accuracy. In this part of the tutorial, I will demonstrate how you can combine and separate 3D bodies. So basically, if you just look at this part, if I just click on this part, so this is the part and there are two bodies. So here there are two parts of the 3D object in one body. Now what I will do is first I will combine them. So if I just click on combine, then target body and tool body. Select solid bodies to combine with the target body. So this is my target body. If I click on here, so one selected. Now the tool body would be the bottom part. So this is my tool body. Now combine, okay. Here you can see the 4-part 3D object become one body. Now how do I split them? To split them you need a plane. So what I will do is if I just go at the origin, if I turn on the origin, I can see a plane here, but I need to make sure it is on the right place. It is just on the bottom of the body. So if I look at this way, I can see it is a little bit up. The 3D body itself is a little bit up. Now I will create a plane. First, let's click. Let's hide the origin point. This is our combined body. Now I will split this body in 4 parts. To do that, I will click on split body. So if I click on it, it will ask for the body to split, which I have already selected. Now as a splitting tool, it should be a plane. So what I will do is I will make a plane first. So offset a plane from the top of the bed to 200 millimeter, which is the exact distance I have drawn the box. The box height is 200 millimeter. So if I click on it, there's a plane created just top of the first box. Here you can see a plane has already been created. Now if I click on it again, the split body, so it will ask for me body to split. I choose the whole body, then the splitting tool, click on it. Okay, here you will see the body become 2 parts. So body 2 and body 3. So body 2 is the top part, bottom part, and body 3 is the top part. Now let's divide these two as well. To do that, we will repeat the same procedure, but before that we need a plane in between. So if I just offset a plane 200 millimeter from this one, so 200 millimeter, another plane has been created. Now split body, body to split, this one, splitting tool, the top plane, click on it. Okay, so now another body has been created. Now the last one I need to make, for the last one I need to make another plane. So offset from this one 200 millimeter up, then split body, click the whole body, splitting tool, the plane. Okay, and here you can see 4 body has been created. So this is how you combine and split 3D bodies. In this part of the tutorial, we will add joint relationship between different components in the assembly. We will use as-built joint. This is an incredibly useful tool for establishing relationship between components when they are in right location in the assembly in relation to each other. So here you can see, as my design approach was bottom-up building, so the components are already in right location. Now let's use the as-built joint. Now first let's do some practicing. So this is an assembly. If I use the as-built joint, so for the as-built joint, just choose the type, and for our look, because of the type of the assembly, we will choose the slider option. So for the slider, it's really important that you choose the component in order. So the first component will be mobile, and the second component you choose will be stationary, and then you give a snap point which need to be in the sliding orientation. What I mean by is that if I choose snap point this orientation, you see it will move this way, but if I choose the snap point this orientation, it will move upwards, but it is difficult for the component to move. So it is basically not giving me the option to move. That's why the snap point need to be in same orientation you want the slide movement. Choose second time. It's not letting me choose. Now let's start again. So as build joint, first component mobile, second component stationary, and the snap point. Then you give the joint motion limit. So for the maximum, here you can see the arrow is pointing. If I just click it, so it's already moved 60 millimeter this orientation, and the minimum I just put it -60. So -60. Rest, I'm not choosing the rest. So if I do that, click on OK, let's see what kind of joint relationship we have just built. So click it. Here you can see it is sliding inside the bigger bracket. We will do the same for our design. So the first assembly, so the first joint, as built joint, the first component will be the mobile X-ray base. So choose the base, then choose the vertical beam, and the relationship would be rigid because I don't want them to be moving in relation to each other. So rigid, then OK, it's rigid now. Now the second joint will apply between these two. If I just zoom a bit, so remember the golden rule of choosing sliding joint. The first component will be mobile and the second component will be stationary. Then the snapping point need to be on the orientation of the slide movement. Then we will give it a limit. So minimum is where it is now and maximum will be you just drag it, holding it and drag it. -400. Let's see the right orientation. So we can give it some more. $500. Maybe 550. No, 520. So the relationship has already been established. Let's try. If I just click it, here you can see it is sliding up and down. Let's build the second joint relationship. As build joint again. So this one will be the stationary for this one in relation to the slider inside. Let's choose the first component inside. It's really difficult, so what I will do is I will zoom in. First component, the mobile one. Second component, the stationary one. Snapping point, this orientation. Here you can see it is already moving. Let's build the joint motion limit. So minimum is where it is now and maximum is should be 500. Okay, so let's see if it's really the relationship has already been built or not. Yes. Now the second joint, same rule again. The first component will be mobile and second one will be stationary. So the first one and the second one, then the snapping point is the orientation of the movement. Here you can see the first one is moving. Now minimum is where it is now and maximum is too much, 500, 300, 300. and no resting. So preview. Okay, let's check it. Yes. Home location. Now the collimator need to be enjoined as well. Collimator will be rigid, but if I choose rigid, the whole assembly will be rigid. That's why I need to build the minimum joint relationship. What I mean by is that I will show you. So it is slider. So if the first one is mobile and second one is stationary, then snapping point any, because I'll give this way. Okay, now I'll give it minimum 0, maximum 0, so it will not move at all. If I do that, here you can see our joint relationship has been established, and it is locating the collimator in relation to the bed in different angle and different orientation. To see it more specifically, with different multiple views. So here you can see the movement from different angle. Let's make it a little bit more visible with a bigger screen. Here you can see the component is doing up and down, back and forth, sliding motion.